The first part we'll discuss Unit 6 from June 2023. We did the first three questions from this. So today we'll do question 4. So in this question, as you can see, a student added small lead spheres to a test tube. The student placed the test tube in a small beaker of a water. The test tube floated as shown. The student gave the test tube a small vertical displacement and the test tube then oscillating vertically, like moving up and down vertically. The student measured the time period of oscillation using a stopwatch. She repeated the measurements of t and calculate the mean. Describe two other techniques she should use to determine t. Like the idea is that how we can determine the time period accurately as possible. So what she should do if she want to measure the time period. So first thing, mark the fiducial points. Fiducial point mean, like example, identification point, so we can identify where is a mean position and where is the extreme position. And record the time for like multiple oscillation, like 20 oscillation and 10 oscillation, and then divide the time recorded by number of oscillation. So what should be done to measure a time period accurately as possible? First thing, mark fiducial points, means the mean and the extreme position, and identification of mean and extreme position. Then record the time for multiple oscillation, like 20 oscillations, and divide the time recorded by number of oscillation. That should be done. The next part is she recorded the following measurement. So student recorded the following measurement. So following measurements were recorded. As you can see, T5 means this is the time for 5 oscillations. Okay, like 5 times the time period, or time for 5 oscillation, 3.43, 3.36, 3.28, and 3.49. Calculate the mean value for a time and its uncertainty. First, we want to calculate the mean value for time, means the time period. So how we can work out the mean value of the time period? First, we'll take a mean of this 5, and then we'll divide it with the number mean of this 4, sorry, not 5. So first we'll take a mean of these 4, and then we'll divide it by the 5 so that we get average for 1. So we have 3.43, we have 3.36, 3.28, and 3.49. If any value appear to be anomalous, like not in the range, we'll ignore that. Remember this thing, okay? So first to take an average, we divide it by 4. So we have 3.43, we have 3.36, we have 3.28, and we have 3.49. And then divided by 4, that is 3.39. So the average for the 5 oscillations, but we want the for T, like for one oscillation. So this is the average for 5 oscillation. If we need 1, so we divide it by 5. So divide this value by 5, you will get 0.678, which is, and because 2 decimal places all the answers, so 0.678, so it will be 0.678. 0.68 seconds. So that is the average for one oscillation. Then for uncertainty of a group data, how to work out the uncertainty of a group data? And we need the uncertainty in T as well. So how to work out the uncertainty? Uncertainty of a group data, it's a maximum minus minimum divided by 2. That is called a half range. So our maximum value is how much? 3.49 according to the minimum value is 3.28 and we divide it by 2. So, but this is the uncertainty in 5 oscillations. 3.49 minus 3.28 and divided by 2. So that is equals to 0.105. But that is the uncertainty in 5t. We want for 1. So how to, so we'll divide this value by 5. Because this result is given for 5t. We need for 1 according to a question. We need for 1. That's why the final answer we divided by 5. So when we divide by 5, we get 0.021, which is because all the values are in 2 decimal places. So we should write in 2 decimal places. That's why it is 0.02. Is it clear how we worked out the uncertainty? So for a group data, the formula for uncertainty is maximum minus minimum divided by 2. But remember one thing that if any of the values in anomalous like not in the range, we'll ignore that. The student estimated the diameter of a test tube was approximately 2 centimeters. Explain why a vernier caliper are suitable measuring a diameter. You should include any calculation. So smallest value which a vernier caliper can measure, it is 0.05 millimeter, or you can also, sorry, 0.1 millimeter is there, or even it is acceptable, 0.05, both are acceptable. So when we calculate the percentage uncertainty for a single set of result, when we have a single value and we want to calculate the uncertainty, for converting into percentage, we'll multiply by 100. But if we want to calculate uncertainty, uncertainty is a value recorded divided by, uncertainty is a least count. Least count means the smallest value which the instrument can record, divided by value recorded into 100. So least count of a vernier caliper is 0.01 is acceptable, 0.1 millimeter is acceptable, or 0.05 is also right. So it's a, because different calipers have different, so both are acceptable, like zero point 0.1 millimeter. So 0.05 divided by value recorded. What value recorded? We recorded the maximum value of 2 centimeter. Or you can like this one. If you have micrometer is 0.01 millimeter and a vernier caliper is 0.1 millimeter. Or 0.05 millimeters are also acceptable. So 0.05 divided by value which we record 2 centimeter, 20 millimeter, or multiply by 100. So this will give us 0.25%, which is a very low uncertainty. So when we have a very low uncertainty, it means the value recorded will be accurate. So smaller uncertainty means less likely we'll make an error in that. The next one, the student replace the water with a different liquid and determine the new value for T. This is a new value for T, student determine, and the formula is given. Show that the density is about 1200. So you have to use this formula. Like this formula is the time period is equals to 16 pi m d square density in gravity. And where d, capital D is a diameter, m is a mass, rho is a density, t is a time period. Now we have to make this our subject as density, because the question is show that density is about. So what you have to do, if you square this equation both sides, so this will become t square is equals to 16 pi m d square rho g, because both sides squaring will remove the root. Now we need the density. So density is our subject. So density will be there in numerator. So the density will be equals to 16 pi m divided by d square t n g. Then you just have to substitute the value. So we have 16, the value of a pi 3.14, and the value for the m. It is given in gram, so don't forget to convert into kilogram. Divided by 1000, so 48.95 divided by 1000. This will convert this into kilogram. SI units are important, so you all should be in SI units. D again, you can see is in centimeters, so I have to convert into meter, so I have to divide it by 100. So it will be 2.38 divided by 100, and then square is there. Then T, which was the time period, 0.61. It's already in seconds, so we don't have to convert the unit. And the gravity is 9.8. So when you solve this, you will get the value for the density, which is about 1190 kilogram per meter cube, which is approximately 1200. The next part, yeah, T should be squared as well. It should be T square. Here I will have T square. T should be squared, because when we took the square both sides, and then T will move in denominator, should be T square, not T. Then show that the percentage uncertainty in the density is about 4%. Look, how we worked out the density, the formula. So the formula which we use to work out the density, this was a formula that density is equals to 16 pi m d square t square g. Okay. There are two ways to do this question. Look, first we find the percentage uncertainty in each value. Like we'll find the percentage uncertainty in m, we'll find the percentage uncertainty in d, and we'll find the percentage uncertainty in t. G is the gravity, which is a constant. 16 is constant, pi is constant. So only these three will have the percentage uncertainties. So first we work out the percentage uncertainty in each value, and then we will add them, we'll get the total. That is one way. Or the second way is like you work out the maximum value of the density and then minimum value of a density, then maximum minus minimum divided by 2. You will get the uncertainty, and to get the uncertainty, percentage uncertainty divided by percentage uncertainty will be uncertainty divided by value recorded into 100. I prefer the first method, like in which I will individually work out the in the mass also. There's no uncertainty in the mass, so mass is also removed from this part. So what we have to do, I'm solving this part. show that the percentage uncertainty is about 4. So how it can be done? Because the values are written here. So if I need the percentage uncertainty in D square. Look, if you want the formula for percentage uncertainty is uncertainty divided by value recorded into 100. We measure D. So, and when you're taking a percentage, you don't have to convert the unit. So uncertainty in D is 0.01 divided by value recorded is 2.38 into 100. Now, because this is a percentage uncertainty in D, but we need D square. So whenever like what power is there, that number it will multiply. If power 2 is there, it will be multiplied by 2. Power 3 is there, multiplied by 3. So when we work out the percentage uncertainty is uncertainty divided by value recorded into 100. So for this one, first we are working out the percentage uncertainty in D square, which is so 0.01 divided by 2.38 into 100. This will give us a uncertainty in measurement of a D. But we need for D square, so then this will be multiplied by 2. So that will give us 0.84%. Then we have to work out the percentage uncertainty in T square. So to work out, first we'll work out for T, because the value of a T is measured here, not T square. So it will be 0.01, the uncertainty divided by value recorded 0.61 into 100. This will give us the uncertainty in T, but we need for T square, this should also be multiplied by 2. If it was T cube, then it will be multiplied by 3. T raised to power 4, then it will be multiplied by 4. So this will give us about 3.28%. Now, what is the total percentage uncertainty in measurement? So we will add simply. There is no uncertainty in 16, no uncertainty in pi, no uncertainty in mass, no uncertainty in g. So the only uncertainties are due to d square and t square. So we'll add the percentage uncertainty of d square and the percentage uncertainty of t square. So 0.84 plus 3.28. That will give us the total uncertainty, which is 4.12%. So that is the total percentage uncertainty in the value for the density. Is it clear? The next is the density of a glycerol is 1260. Deduce whether the liquid could be glycerol. Okay. Look, there are two ways again to solve this question. The best way is compare the percentage difference with percentage uncertainty. Okay. If you find that the percentage difference is more than the percentage uncertainties, then you will say the values are not same or not equal. And if you find the percentage difference is less than the percentage uncertainty, it means the values are same or equal. So what we will do, we'll compare the percentage difference with percentage uncertainty. The percentage uncertainty in our last part, we got 4.18% in the density. The percentage uncertainty of the percentage uncertainty in our value of density was 4.18%. So what we will do, we will compare the percentage difference. How to work out the percentage difference? Percentage difference, try to learn these formulas. Percentage difference is equals to maximum minus minimum divided by, it can be average. If we look, if we have a standard value, then the formula is percentage difference is maximum value minus minimum value divided by standard value into 100. But if we don't have any standard, like if we don't have any standard value, then and two values are there or three values are there, then it will be maximum minus minimum divided by mean into 100. But in this case, we have a standard value that is for glycerol. The standard density of a glycerol is 1260. And when we did this experiment, our value is 1100 and it was the last value which we calculated. It was 1190. So our value was 1190 kilogram per meter cube. Now we want to calculate the percentage difference. So percentage difference is the maximum value, because in these two, which is the maximum value, 1260 is a maximum, 1190 is a minimum, and we have the standard. So we'll write 1260 as a standard into 100. So when we multiply, it will be 5.6%. So percentage difference is 5.6%, and percentage uncertainty, which we calculated in the previous part for the density, was 4.18%. So percentage difference is higher. If the percentage difference is higher, then this substance or the two values are not equal, or liquid may not be glycerol. Is it clear? That how we compare. So this is a very common type of a question in exam. As we'll do different past papers, you will find discussion repetition is there, that in which you have the last part usually, which you have to compare the two values are equal or not equal by percentage difference and percentage uncertainty.